Now, the second thing that we're going to look at today, guys, is going to be solving problems that have multiple equations that require us to write these equations for these different scenarios here. You may have heard these referenced as a system of equations. Those mean the exact same thing as simultaneous equations. Now, we've got the scenario here. So we got 2 adult tickets and 3 children's tickets are $45. 3 adult tickets and 4 children's tickets cost $64. And we have to find the cost of each ticket. So the first thing that we've got to do to solve this problem is we're going to have to set up a system of equations here. Now, the 2 variables that we've got here are the adult tickets here. So I'm going to use adult tickets and these children's tickets as my variables. So I'm going to use an A to represent the cost of an adult ticket here because that's what we're trying to find here. And I'm going to use C to represent cost of a child ticket. And so that is what we're trying to solve here now. So then what we can do is we can write an equation that represents this. So if I get 2 adult tickets, which I'm going to represent as 2A, and 3 children's tickets plus 3C, that's going to be equal to $45. So that's the first equation right there. Now, as of right now, I can't solve this equation because we have 2 variables, no math operations we can currently do with that. We'll solve that. The next thing that we can do is, okay, 3 adult tickets, so that would be, in this other scenario, 3A plus 4C equals 64. Now, what we can do now is these equations, A and C, are both the same values here. So we can perform math operations across these equations. We can add these equations together. We can subtract these equations. We can multiply one equation by something because they're A and C are the exact same values here. So what we want to try to do is we want to either try to get rid of A or we want to try to get rid of B here or C here. So it doesn't matter which one that you pick, but I'm going to choose to get rid of A here. If you want to choose to get rid of C, you are more than welcome to do so. So what I'm going to do that, I've got to get A and both of these to be the exact same number. So to do that, I'm going to have to say, okay, if I'm multiplying here, what is the first number that I can get 2 and 3 both to? And if by multiplying, and that number is 6. So what I'm going to do is I'm going to multiply this by 3, and I'm going to multiply this by 2 here. So I'm going to write the new equations over here. Actually, I'll just bring them down here. So that's going to give us, the first equation is going to be 6A plus 9C equals 135. The new second equation here is going to be 6A plus 8C equals 128. And what we've got now is a system of equations that what we can do is say, okay, well, both of these have 6A's. We can go ahead and cancel out those 6A's. So we get 6A and 6A to cancel out by subtracting. So we're going to actually subtract this whole thing. This process, for those of you who remember, is called elimination. So we're eliminating these 6A's right here. So these are going to cancel out. 9C minus 8C is going to give me just a single C. 135 minus 128 is going to give me 7. So now the cost of a child's ticket is 7. So then what we've got to go and figure out now is, now that we know a child's ticket is 7, we can use either one, any of these 4 equations. I'm going to opt to use one of the first 2 because it's smaller numbers. So before I do that, I'm just going to write child's ticket is $7. And then we'll substitute into the first one here. So it's 2 times A plus 3 times 7 equals 45. We're going to solve this equation over here for it. So 3 times 7 gives me 21. This is 2a plus 21 equals 45. And we can now solve this equation. We'll say, all right, minus 21 from both sides. That's going to give me 2a equals 24. So 2 times a number equals 24. That number is going to end up being $12. So the price for an adult ticket is $12 in this case. And again, you can always substitute those numbers into both equations to make sure that is a unique solution. Another way to solve these, I'm not going to do this in this example particularly, but if you want to set those up to where it's A equals something or C equals something, you could actually go and graph both lines and see where they intersect if they have one solution point. And so the last problem that we're going to look at here, it's going to be very similar. We've got a hardware store that sells 3-liter cans of paint for $36 and 5-liter cans for $48. On one day, the store sells 71 liters of paint worth $768. And what we want to know is how many cans did they sell total. And so the two types of variables here that we've got are we've got these 3-liter cans. And whenever you're writing a system of equations, you need to figure out what are my what are the two things that I could write an equation with here. Because when you're writing a system, you need to first off say, okay, the variable I'm going to use to define these. So we've got 3-liter cans, since they're both liter cans, let's just use X and Y. We'll say X equals the number of 3-liter cans. We'll say, all right, well, Y is going to be the number of 5-liter cans. And so what we can do from there is try to set up a system of equations that uses that. So we know that we sold 71 liters of paint. So we've got to write a system for that says we're going to have to multiply X times 3 to figure out the total amount of liters plus 5 times Y, and we're going to set that equal to the total number. So this right here is our liters equation. Our liters equation right there. Now, the other one that we've got to write is for the money. So from here, we're going to say, all right, well, it was $36 for a 3-liter can, and it was $48 for a 5-liter can. And in total, that was $768. So this is our cash equation right here. And so what we've got to do now is we've got to look and we've got to see, okay, what is the closest thing that we could get X or Y to? And so looking at X's here and looking at Y's, I'm trying to figure out what the least common multiple is. What is the smallest thing I could get either X or Y to be? And upon looking at it, it looks like the X's, I think the Y's would actually be like 200 and something if you wanted to multiply that. But you can get 3 into 36 pretty quickly through multiplication. So that's what we're going to do. We're going to take that liter equation and we're going to multiply it times 12 here. We don't have to multiply this one by anything. So let's see. That's going to give us 36x plus 60y. I think 71 times 12. Let's see here. It would be 840, 852. So 852. The other one we've got is still the cash. So this is still our liters equation here. 36x plus 48y equals 768. And very similarly, what we did on the last problem, we're now in a place where we could subtract this equation, because these equations are working together in this scenario. You are allowed to freely multiply one as long as you do it to the entire equation. You can add these things together, you can subtract these things together, and it's going to make our lives a lot easier if we can get rid of one of these variables. So these 36's are going to cancel out. 60 minus 48 is going to give us 12y. 852 minus 768 is going to give us 84. And so what we're left with is that 12 times the number of 5-liter cans equals 84. Well, that means that y is going to equal 7. And so the last thing that we've got to do here, we figured out that they sold 7 5-liter cans. We have to figure out how many 3-liter cans they sold. So again, you can pick any of these equations to substitute into. Again, I'm going to opt for the first one because it's easier to substitute into. So we've got 3x plus 5 times 7 equals 71. So that's going to give us 35. So 3x plus 35 equals 71. Doing a little bit of algebra, we're going to subtract 35 from both sides to get that 3x equals 36. 3 times a number equals 36. That number has to be 12. So we sold 12 3-liter cans and 7 5-liter cans. So I will have a homework assignment posted for you on Canvas. The books, as of right now, still are not in. I will let you all know as soon as they come in. And if you all have any questions, please let me know through Zoom, through Google Chat, through email, whatever works best for you.